In this video, we want to find the radius of convergence of the following series. Well, this is a classic ratio test, so let's look at the n plus first term over the nth term. So we're going to substitute n plus 1 in for n, and then we're going to divide that by the original sequence here. Okay, now what I have here is this as a fraction, and then this as a separate fraction. So this will be the top, the numerator, this will be the denominator, and this is the numerator, this is the denominator. So I split it up into two separate fractions, and now this is much easier for me to simplify. Well, first, this is 3n, so 3n minus 3n is 0. That cancels, and what I'm left with is 3 in the exponent. In the next one, we have a to the n over a to the n plus 1. The n's going to cancel. I'm just left with 8. And then I'm just going to leave 2n plus 1 over 2n plus 3. And now I'll just distribute the 8 to get 69 plus 24 in the denominator. And so now I want to take the limit as n approaches infinity. So because this is inside the absolute value, the x does not depend on n. Right? The limit is in terms of n. So because this is not n, you treat it like a constant. So you can pull it outside. And because it's absolute value, the negative just goes away. So technically, you don't even need this absolute value. So 2n plus 1 over 69 plus 24, you just really look at the degree, the highest term in the top and the bottom. It's like 2n over 69 is 2 over 16, which is 1 over 8. And then we're going to multiply that by x cubed. So actually, you should keep the absolute value because now you want this to be less than 1. Which means if I multiply both sides by 8, I want the absolute value of x cubed being less than 8, or x cubed being between negative 8 and 8, which means x will be between negative 2 and 2. So that's by cube rooting both sides, or all three sides. And now it's just a matter of testing the endpoints. So if I let x equal negative 2, I plug it into the original problem here. So instead of negative x, that becomes positive 2, and then raised to 3n. Now, whenever you have 2 to 3n, I can rewrite this as 2 cubed raised to the nth power, which is 8 to the nth power. And now that's going to cancel with this 8 to the n. And we know 1 over 2n plus 1 diverges because of the p-test. So now we have to test x equals 2. So plug into this top equation here, top series. And then, again, negative 2 cubed is negative 8. Raise that to the nth power. So the negative 8 is technically, the negative is part of the exponent. So whenever I cancel, so I guess I should write it like this. I should have negative 1 to the nth times 8 to the n. So that's what that numerator equals. So the 8 to the n is going to cancel, and I'm left with negative 1 to the nth power over 2n plus 1. And we know that converges by the alternate series test because this is alternating, limit goes to 0, and 1 over 2n plus 1 is decreasing. So we conclude to say do not include negative 2, but include 2. And so this is going to be the interval of convergence.